All right, hello everyone. Wanted to go over a few problems and make a video just to explain a few things. Some of these problems are from the quizzes, some are from the review, some are from online. It's just a mixture of things here, okay? So for this first one, just as a review for domain and range and increasing and decreasing, okay? So I'm actually going to go out of order a little bit. So for increasing and decreasing, remember we only use parentheses and we only use x values, right? We're observing y values, but we're actually writing the x values here, okay? So it's increasing. You can tell from this point here, right, that I'm marking here in red. So from here to here, right, there's this segment that hopefully it's obvious that it's increasing. And where is it happening? It's happening from x equals -3 until x equals 1. So from -3, comma 1. All right? And it's also increasing from here, right? This y value of 1 all the way to infinity, but it's happening at x equals 3. So we're going to say the union of 3 comma infinity. Okay. For decreasing, you can tell that it's decreasing from, and I'll make it green here, so from this y value of 3 down to this y value of 1, but it's happening at the x values of 1 to 3, right? So it's decreasing from 1 to 3. And I think that's the only place where this function is decreasing, okay? All right, so for domain, and I think I wanted to review this because I think there's still a little bit of confusion, but domain, remember, is a couple ways to think about it, right? What's the minimum x value? What's the maximum x value? Or how far left does this graph go and how far right does this graph go? All right. So how far left does it go? The furthest left point is right here in blue, right? Because it's a closed dot, right? And there's no arrow, so it doesn't keep going to negative infinity. And because it's a filled-in circle or a filled-in dot, it's at -6. So I know that it begins at -6, and I'm going to have a bracket, okay? And then, what's the farthest right it goes? There isn't, right? It just keeps going to infinity. Yes, it's increasing. The y values are getting higher, but it's also going to the right as well. So this is -6 to infinity with parentheses. For the range, we ask how low and how high, right? What's the lowest y value and what's the highest y value? And so for this one, the lowest y value is -1, right, along this segment here. Okay, so these are all included, right? So it's going to be a bracket -1, comma, and what's the highest y value? There is none because it keeps increasing, all right? So that's going to be positive infinity. Okay. So the range is the only time that we use y values in the interval, right? Domain uses x, increasing and decreasing uses x. Okay? So hope that was helpful. So in this next one, I wanted to just quickly review how to determine the domain, especially when you have a rational function, right? Meaning a fraction. All right. So in this one, we know that the bottom cannot equal 0, right? And so we also know that because it's a square root, you can't have the inside equaling less than 0, right? Because you can't take the square root of a negative number, all right? So therefore, this x minus 5 must be greater than 0, okay? Strictly greater than, not greater than or equal to, but greater than 0. So when you solve this, right, you're going to add 5 to the other side. That's going to be x is greater than 0. Okay. I'm sorry, not greater than 0. Right? X is greater than 5. Sorry about that. Okay. So if x is greater than 5, that means 5 is the smallest value, right? That's the smallest x value without including it, right? And then it goes to infinity. Right? And so both of these get parentheses because this is strictly greater than 5. Okay. Now one thing I want to point out, so this is the domain for h of x, okay? But let's suppose that your function was just the square root, okay? Without the fraction, all right? And so if it's just the square root of x minus 5, for this one, it can equal 0. So this would be greater than or equal to 0, right? Because there's no like this, the square root of x minus 5 is not in the denominator. Okay, so inside the square root, it can equal 0 because the square root of 0 is just 0, right? So, but in the one that we did in green here on the left-hand side, okay, we have to use only greater than 0 because it's in the denominator, right? The denominator can't equal 0, okay? All right, so here determine the domain, okay? Again, when you've got a rational function like this, and we're getting a little bit of practice into chapter 4 actually, we got to look at the denominator, right? So we got to think what value of x will make the denominator equal to 0, because whatever that value is, it will not be in the domain, right? So if I set this equal to 0, and if I solve this, I get x equals 3. So x actually cannot equal 3, right? Because if you do plug in 3, then it makes the denominator equal to 0, okay? So 3 is like the cutoff, right? X cannot equal 3, okay? If you have a number line, right? If you have 3, you can have anything to the left of it, okay? You can have anything to the left, you can have anything to the right. They would all be part of, you know, you can plug those in for x, but at 3 you cannot plug in 3, all right? So therefore, the domain here is going to be negative infinity, comma 3, with parentheses because x cannot equal 3, okay? Union of 3 comma positive infinity. Okay, so this blue interval, right? It's a way of saying the red. Okay. Now, one thing I also wanted to, or two things I wanted to go over is reviewing x-intercept and y-intercept for these types of problems. Okay, I'm going to start with the y-intercept. All right, y-intercept means that x is equal to 0. Right? Which means I'm plugging in 0 into my equation for x. So that's going to be 6 times 0 over 5 times 0 minus 15, right? So I get 0 over negative 15, and that equals 0. So that means the y-intercept is at 0, 0. Okay? I plugged in 0 for x, and the y ended up being 0. For the x-intercept, that means y is equal to 0. Okay? Now that means I'm setting the equation equal to 0. I have 0 equals 6x over 5x minus 15. I can multiply by the denominator, right, to both sides, right? Doesn't matter. On the left-hand side, that's just 0 again, right? So really you have 0 equals 6x, and x turns out to be 0, all right? So that means the x-intercept is also at 0, 0. Okay, so for this particular function, the x and y-intercept is at the same place, 0, 0. Okay, if you need to rewind and look through this work for x-intercept and y-intercept, I think that'll be really helpful. And then wanted to go over even and odd. Okay, so remember you always start by plugging in negative x, right? Okay, and you get negative x, and then over, oh, that's to the fourth, isn't it? It's an even exponent, so this is x to the fourth and minus 8, right? Okay, now if you take out a negative, right, you get x over x to the fourth minus 8. Okay, and so after we take out the negative, okay, so at this step right here where I'm drawing the arrow, it's not the same exact as the original equation, so it's not even at this point. Okay, that's why we take out a factor of a negative, and then if it's the same inside the parentheses like it is right now, then this is an odd function. All right, so for this one, right, what happens to the coordinates of y equals f of 2x and then plus 1? Meaning these are the transformations, right? Okay. So we know that this will go up 1 because of the plus 1. And the 2x, right? Remember we talked about in class, what do you have to multiply by to get this back to 1x? Right, I'll say that again. What do you have to multiply by to get this back to just 1x? And so you have to multiply by a half. All right. And so for the y values, the y coordinates, okay, the y values, you're adding 1, right? Because you're going up 1. Okay. For the x coordinates, okay, you are multiplying by 1/2. Right? So this is going up 1. If you're multiplying by 1/2, this is a horizontal compression. All right. So I wanted to review that. I'm going to also do a piecewise video, so please watch that as well.